In this video, I'm going to describe the different sets of numbers and interval notation. Here you can see the different sets of numbers that we'll deal with most frequently in pre-calculus. Now, before I start going through them, I do want to point out this note here on the side that if I point out a number is in one of the sets, like say the number 2 is a whole number, you'll notice that it is also in all of the sets connected above it. So 2 is also an integer, 2 is also a rational number, 2 is also a real number. It is not an irrational number, so don't go to the side. And it is also a complex number. So do keep this in mind whenever we refer to a number like 2. Make sure that you understand that it's actually within multiple sets, but sometimes we'll focus on saying what is the smallest set that it belongs to, in which case we'll just focus on it being a whole number. Now, starting with the biggest set of numbers we have here, the complex numbers includes both the real numbers and the imaginary numbers. We don't use the imaginary numbers very often. These are the numbers you get from square rooting a negative number. They are often indicated by having an I value, which represents the square root of negative 1. So there will be some times where we're going to use imaginary numbers more than others. And a pure imaginary number would be a number that doesn't have both parts, real and imaginary. It only has the imaginary piece. That's why the A value is 0 in this case. On the other side of that, there's the pure real number. Real numbers, instead of having a number for both parts, the real and the imaginary part, they don't have the imaginary part. This is one of the more important sets that we'll be dealing with because a lot of times our questions will refer to a real value or they might say a rational value. They're pretty similar in most cases. This is going to be your numbers like 7. It's going to be your infinite repeating decimals. It's going to be those weird numbers like pi that go on and on and on. So most of the numbers that you perform mathematics operations with are generally going to be real numbers. Now within the real numbers we have two smaller sets. We have the rational ones, which are the ones that can be written as a fraction. So like 7 over 4, 1 over 3, those are numbers we can write as a fraction. But you also have to be careful about the decimals because something like 0.5, that could be written as 1/2. So that does count as a rational number. It might be easier to describe a rational number by comparing it to the other set, the irrational numbers. These are the infinite non-repeating decimals. So again, there's that weird number pi that we mentioned earlier. There's another very similar number, e. And probably the ones you'll see the most in this class are the non-perfect squares. A square root of 4, well, that would count as rational. You could write that as a fraction if you wanted because the square root of 4 is just 2. But square root of 2 doesn't reduce. So this is an infinite non-repeating decimal. So square root of 2, square root of 3, square root of 5, all of those are the ones you'll encounter the most whenever we're talking about the irrational numbers. Coming back to the irrational, there's a smaller set of those. If we're not talking about the fractions and decimals between, the integers is just those numbers 0, 1, 2, and 3. So we're not counting the fractions and decimals between 0 and 1. Now, the difference between the integers and the whole numbers is the integers includes the negative versions as well as the positive versions, whereas the whole numbers only includes 0 and the positive numbers. There's another slightly smaller set that I didn't include on the diagram. They are sometimes called the counting numbers or the natural numbers. It's basically the exact same as the whole numbers you see here, but they remove the value 0. It's a very tiny difference between the whole numbers and the natural numbers, so I didn't draw it on the diagram, and a lot of times that distinction isn't made when you're given directions on a question to use one set or the other. Now, sometimes in math, you may come across a question where there are multiple answers to it. And there's actually a notation in math for listing out having multiple answers rather than just separating them with a comma. We want to make sure we don't confuse it with things like an ordered pair or what we'll be talking about in a moment, interval notation. So if you just have several numbers that you need to list out for an answer, and you're not trying to include any of the fractions or decimals or anything in between, you're literally just using the numbers that you specifically write and separate out with commas, we use these curly brackets, or sometimes they're called braces, that look like this. You should be able to find a key that has these symbols on your keyboard. So for an example of where you might be listing out some specific numbers and not anything else outside of that, like the decimals and fractions in between them, a question could say, what are the even integers between 5 and 13? Well, we just talked about what an integer is. So if we were looking at all of the integers between 5 and 13, you'd have 6, 7, 8, 9, 10, 11, and 12. However, this specified only the even ones. So that's where you can see I have listed out with the curly brackets that I have the integers 6, 8, 10, and 12. The other numbers like 7, 9, and 11 are not even integers between 5 and 13. So I need to be able to emphasize that it is just these specific values that I'm listing. It doesn't matter how many you have. Usually you won't have a question that has too many different numbers inside of it. So if you have a situation where you have multiple answers to provide for a question, we use these curly braces and we just separate them out with commas like so. Now this part is the real heart of this video lesson. Interval notation is what we will use most frequently when we have a situation where there are many answers to a question. Interval notation is used to list two endpoints. So you're going to have a smallest number and a biggest number, and we're going to be counting all of the infinite numbers of decimals and fractions between them, because it's actually impossible to try to list out all of the fractions and decimals between any two integers like 6 and 7, because you could start listing them off as 6.1, 6.2, 6.3, but then there's also 6.01, 6.02, 6.03, 6.001, 6.002. So it's impossible to list all the fractions and decimals between any integers. So the interval notation is going to help us come up with a system to say these are the endpoints, and we're also talking about all the numbers in between them. Make sure that you always list the smallest number first. So think about a number line. Whichever number is farther to the left on the number line needs to go farther to the left on the interval notation. Your biggest number will be the number that's farther to the right on the number line. That number always goes second. So the number on the right of the number line is the number on the right in the interval notation. Now, the other thing that can be tricky with interval notation is sometimes we are including the endpoints themselves for the interval that we write, and sometimes we are excluding the endpoints. If you are excluding the endpoints, then use parentheses symbols. So if you want numbers really close to 3, but not 3 itself, like 3.001 is fine, but 3 is not, you would use parentheses on the 3. If you do want to include the endpoints on the interval, so you're saying, yes, I want 3 and the numbers really close to 3, like 3.1, then you will use a bracket on that endpoint of 3. It is possible to have one of the endpoints using a parentheses symbol and the other endpoint using a bracket symbol. So each endpoint needs to be considered separately for which symbol you should use. You can mix and match them. Many of our intervals will have an infinity symbol, either a negative infinity to indicate the far left of the number line or a positive infinity to indicate the far right of the number line. Always use parentheses for those because the idea is that you're never actually hitting that infinity. It's not possible to actually hit the largest number, so we use parentheses to denote that. I expect you guys already have some experience working with inequalities, so I'm going to use this as the first quick examples on how to write an interval answer. Now, many times figuring out the interval notation can be easier if you sketch a quick number line for yourself. So I've done that here underneath to help with getting my interval notation answers. On the first example I'm going to show you, we have all of the numbers bigger than 3. So I know something is happening here at 3, and specifically I want the numbers bigger than 3, so that would be the numbers like 4, 5, and 6. It's easy to see that on the number line. So I know that I want to have the numbers going to the right of 3. Now, whether I use the parentheses or the bracket is indicated by the inequality symbol. Remember, if there's no line underneath, that just means the number's bigger than 3, not bigger than or equal to 3. The line underneath is when you include the or equal to. So since this just says the number is bigger than 3 but not equal to 3, I would use the parentheses symbol to indicate this. Well, that's actually going to be the same setup I use for my interval notation. My smallest number, according to this number line, is 3. Now, my biggest number, since this just has an arrow pointing to the right forever, that means my biggest number is infinity. So these are my two endpoints. Now, we said that it was a parentheses on the left side because it's not greater than or equal to 3. And on the last slide, I told you that it's always parentheses for the infinity symbols. So this would be the interval for all the numbers bigger than 3. Here's the second example. I have the numbers less than or equal to -1. So here's -1 on my number line. If I want numbers smaller than -1, that actually means like -2, -3, -4, etc. Numbers like 0 and 1 are bigger. Now this one does have the line underneath, so since I know that my arrow is pointing to the left side of -1, I'm going to mark the endpoint with the square bracket this time. This time we are including the -1 for my endpoint. So here's my number line graph. For writing the interval notation, my smallest number going to the left forever is -infinity. There's no smallest number, so we put a negative symbol in front of the infinity. The biggest number I ever hit in this interval is -1. For determining whether it's parentheses or brackets, remember we said we always use parentheses for the infinities. And since this one does have the square bracket here, or since I'm looking at the inequality and I see the line underneath the inequality symbol, that means I do need to use a square bracket on the -1. So you can have a mix of parentheses and square brackets on interval notation. And then one last example, I have the numbers between 2 and 5. I am including the number 2 itself, so that's going to be a square bracket. On 5, it's just the numbers less than 5, not including 5. So that one's going to be the parentheses and the numbers in between. So by drawing the number line, it's going to be really easy now to figure out my interval notation. My smallest number was 2. My biggest number was 5. And we said not including 5. I already figured out that this is going to be parentheses on that endpoint. And we said we are including 2. We already figured out this is going to be a square bracket. So this is telling me all of the numbers between 2 and 5 are answers to this. That includes the infinite number of decimals like 2.3, 2.4, 2.5, etc. Here's a couple more quick examples as word problems this time. Again, I've drawn out number lines to kind of help identify which numbers will be part of our answer and which numbers won't. So for the first one, I have list all the prime integers between 10 and 20. So if I have these all written out, it's a lot easier to just go through and say, is 11 prime? Yes, it is. It's also an integer. 12 is not prime. 13 is. 14 is not prime. 15 is not prime. 16 is not prime, but 17 is. 18 is not prime, 19 is. So since this one was just the integers, I didn't have to worry about any of the fractions and decimals between. That's why this is a good case for using the braces symbol of just listing out specific values. On the second problem I have here, interval notation, because we're going to describe all of the real numbers. And remember, real numbers do include those fractions and decimals from the diagram I showed you earlier. We want greater than or equal to 7. So I know something is happening at 7. Greater than 7 means I want the numbers to the right-hand side, so we would use the square bracket because it says to include the endpoint of 7 itself, and then we want this going to the right. So I would use a square bracket on 7. My biggest number, it never stops, so my biggest number is infinity, and we always use parentheses with the infinities. So that's the end of my first video of pre-calculus prerequisites. I hope the looking back at interval notation was especially helpful because we will use this a lot when we start talking about domain and range again over the coming lessons.